All right, welcome back everyone. There is one last thing we have to do with factoring before we take our factoring test, and that is talk about the special cases of factoring into binomials. So um, we'll just get started going through these examples, and hopefully you'll be able to see what's going on with these. So with these two examples, if we look at the first one, what we are going to focus on are two things. One is the fact that this is x squared, and the fact that 36 can be written as 6 squared. And what you'll notice is 6 squared is 6 times 6. And 6 times 6 is 36. But then also 6 plus 6 is 12. So that's a really important thing to notice. If you can find two perfect squares like x squared and 36, and if the factors add up to the middle term that's in the trinomial, then we have what's called a perfect square trinomial. And if we have a perfect square trinomial, we can just factor it into two binomials where the binomials are exactly the same. So we have x plus 6 times x plus 6. And what we can do then is write our answer in a little bit more simplified form where we just have one binomial and we put an exponent of 2 on the outside to indicate that it's multiplied by itself. All right, so I didn't go through making the list of factors for 36. I really easily could have done that and said it's 1 times 36, 2 times 18, 3 times 12, or 6, sorry, we got to get 4 times 9 in there, 4 times 9, and 6 times 6. I easily could have done that, and I could have identified that, hey, this one is the one that adds to 12, and factored the trinomial that way. But if you recognize that you have a perfect square on both ends of your trinomial, and the middle term happens to be the numbers that are multiplied together to equal the number on the right, if it happens to be those two added together, then you can just go ahead and do what we did. All right, let's look at another one. In this case, we have x squared minus 16x plus 64. So if we go ahead and make the list this time, so 64 is 1 times 64, 2 times 32. 3 doesn't work. 4 works, so it's going to be 4 times 16. 5 doesn't work. 6 doesn't work. 7 doesn't work. But wait a minute. 6 does work. It's 6 times 8. All right. So like we've said in class, if you are going through this list and you can't quite figure these out, grab a calculator and just start dividing 64 by numbers to see what works. And if you go in order on the left-hand side like I did, 1, 2, 3, 4, 5, 6, you'll be able to get them all pretty quickly. Okay, so wait a minute. It's not 6 times 8. What am I thinking? It's 8 times 8. So let's go ahead and get rid of that one. Whoops, I got rid of too much. I'm going to write, oh no, let's just do it all again. All right, so here we go. Let's do 64. 1 times 64, 2 times 32, 4 times 16, 6 times 8. What was I thinking? 8 times 8. All right. So we have 8 times 8, and that's the one that we want to focus on because 8 plus 8 is 16, but since it's negative 16, both the numbers need to be negative. So we're going to write this as x minus 8 times x minus 8. And then we could also write it as x minus 8 squared. All right. Yeah. So I made a mistake. That's all right. It's good for you to see that. Okay, here we go. You have 2 to do on your own. When you're done with those, make sure you remember to enter those in Schoology, and you can restart the video and we'll continue talking about some special cases. All right. I'm trying to figure out what goes in this blank here. These were all special cases because when factored, they create a... I wonder what the teacher who made this intended. I'm going to put a question mark in there because I don't know for sure. I don't know what was intended for that. Well, let's just ignore that. All right. The second set of um, special cases involves something that doesn't even look like a trinomial. They have a squared term and they have a number, and that's it, a number that's called a constant. Um, they're missing the x term in the middle, but we could go ahead and write the x term in the middle if we wanted to, and we would write it in there with a 0 next to it. And we could go ahead and factor this the exact same way, where we do 1 times 81. 2 doesn't work. 3 works. We have 3 times 27. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 doesn't work. 8 doesn't work. But 9 does. 9 times 9. All right, now what we should notice is that the number that we're going to be adding or subtracting to is 0, because we have that 0 term in there. So if there's no term in there, we just have to find two numbers that when we add them together, they cancel each other out. And that's going to be our 9s here in this case. And so again, it's another type of factoring that involves two numbers multiplied by itself, right? And in this case, if we have a 0 and we have a negative 81, one has to be negative and one has to be positive. So this is a little different type of factoring of something with a square in it. And in this case, it's called the difference of squares, because we have a squared term in the beginning, that's x squared, and we have a squared term at the end, that is 9 times 9. And there's a subtraction sign in between it, and subtraction means difference. So that's why we call this the difference of squares. All right, let's do another one. And let's do this one a little bit more quickly. Let's not think about making that list and everything. Let's just think about the fact that 100 is 10 times 10. And the only way I'm going to get negative 100 with 10 and 10 is to subtract 110 and add 110. So I'm going to have x plus 10, x minus 10. Okay, so these should be able to start to do more quickly if you notice, hey, this is a squared term, this is a squared term, and I've got subtraction between them. 10 times 10 is 100, so it's x plus 10, x minus 10. All right, and then this last one looks different than all the rest because of this plus sign right here. And anytime that you have something that looks like you should be able to factor it because it's a difference of squares, but it has a plus sign instead of a minus sign, this is considered not factorable. There's no way that we can find two numbers that multiply to equal 25, but then cancel each other out because it's positive 25. Okay, so we could look at the list, and we could say, can I take 5 and 5 and add them together so that they equal 0? Well, the only way I can do that is if one of them is negative and one of them is positive. Well, if one of them is negative, that means that the 25 is going to be negative instead of positive. So this one is not factorable because of that. All right, so something to watch out for. Somebody might try and trick you someday. All right. And they're going to do it right here in the 3 that you have to do on your own. All right, so the 3 that you have to do on your own, make sure you do those, and when you are done, make sure you submit your answers in Schoology. And this blank down at the bottom, let's see if we can figure this one out. The term that is used to describe these types of problems is the term. I mean, there's a phrase, I told you already, it's the difference of difference. Let's just put the word difference in there. And difference means subtraction. That's a subtraction sign. All right, there you go. You've got enough to be able to do this, so let me know if you have any questions.